Okay, this is the Miwa LS7. It's a cam lock with 7 spring-loaded sliders inside the lock. What's interesting about this lock is that you're able to rekey the bitting of the key without actually disassembling and reassembling the lock. Let's see. We have two different keys. These are both operating keys, and as you can see, they have different bitting. It's currently set to this key. If we demonstrate this using this key, simply opens the lock very well. The other bitting key, you can insert it, but no, it doesn't work. Now we also have the change key. We're going to explain how the whole bitting changing mechanism works in a while, but for now I'm just going to demonstrate how this thing basically works. So currently we are set to this bitting. So we have the change key with the same bitting. Wait, no, it's this one. Yeah, we have the change key with the same bitting. We insert the change key. We can turn it as well. We go 180 and we remove the key. And then we insert a new key, the key that we want the bitting to be changed. So it's this one. We insert that. We go back to the neutral position. And then now this key works. But the old key does not work anymore. Simple as that. So before we go on to the explaining part, we are first going to pick this. As we said, we have 7 sliders total. 4 sliders are on this side, 3 sliders are on this side. They are alternating to this way and this way. So we are going to pick it with 2 tensioners because the slider nubs are on either side, and it's kind of tricky for me to work with only 1 tensioner. And I'm going to use this simple short flag, custom made flag, and let's try it. The sliders have false gates as well, and they bite pretty hard. So basically you gotta pick this lock like you would pick a Japanese lever lock, because they are locking into the false gates and they lock in pretty deep and hard. So it's best to set those sliders that have false gates before true gates. So the max lives, as you would say. Let's see, this is binding. Release a bit of tension, just a little bit. Drop a couple, but I think that one's set. Let's see. No, still not set. One more click. Okay, yeah, that's set. This one's set. The back one as well. Okay, I think the 3 slider side is probably set. Let's test it out. This one's set. Let's see, this one. Okay, this one dropped, I think. Let's reset it. Yeah, I think it's set now. The inner ones, let's see. I think there's one binding, but I can't tell. This is set. This is set as well. This is set as well. Oh. think it's open, but why am I might be blocking with the tensioner. Let me try it on this side. Yeah, there we go. My tensioner was probably blocking one of the sliders there. But yeah, see, so it's not a really tricky pick. It's relatively simple if you figure out the false gates and true gates of the sliders in it. Yeah, I think my tensioner was blocking the most foremost slider on this side. But yeah, guess that was not a big deal, but it's done. Okay, so now we gotta explain how the change mechanism works. So in order to do that, we first have to disassemble the lock. And if you happen to own this lock, I do not recommend disassembling this, because it's going to be a pain in the ass, and second, it's going to be a pain in the ass to reassemble if you fully disassemble it. I'm just doing this for demonstration purposes. There's a rotation limiter here, but this nut is very weird and it does not want to screw in deeper, so I could not make this secure, but I just made sure to pick the way that it was intended to, so that not the way that the rotation limiter would limit if it was active. So we first screw this nut. Why is it so tight? There we go. Loosen that up. And we have this little housing thingy that holds. Let's just remove these as well. We don't really need them for demonstrating. Okay, now one of the core important parts of the change mechanism is there is a holder that does multiple things. Where is it? Okay, so there is this, let me zoom in a little bit closely. Okay, so there's this little metal piece that's basically holding the core of the lock to not slide out, because without this it will, because there's no like C-clip or anything holding this lock, so it's basically being held by this little metal piece, and this metal piece is kind of friction fit into this thing when it's initially. So to remove this, you have to do a lot of things. You kind of have to go this way, and wobble it for a few hours. I did that, so it's not going to be hard for me to remove it. So, and there's also another reason why there's a metal piece holding, but that's going to be explained pretty soon. So I kind of filed the sides of this piece after I initially removed it, so it's going to be easier for me. Just like that. Make sure I don't slide the core out, but this is that little metal piece. This basically holds the core into one piece. Now I have to make sure I do not remove the key. Should I be using the change key, or I don't think I need the change key. I'll just use the operating key. Put the key in. Keep the key in. Okay, there we go. This is the sidebar. The sidebar is just a metal piece that goes in the core. Two springs as well. Now this is the interesting part. How could I show you this better? So this one is like, this is not a true slider. This is just like a, let's say it's a spacer. This does not have any gates. This doesn't interact with the key or whatsoever. So this core is basically in two pieces. This upper part, as you can see, this kind of moves in and out. Whew. Okay. There's this little metal piece. So this part it moves like this freely. There's nothing holding back. So if I do this, this thing will literally slide off. So what this part do is that this part is where the sidebar is. So okay, so the sidebar is going to push in. So if the gates are all aligned well, the lock will open. So this part is actually the slider part where it interacts with the sidebar. As you can see, these have teeth, and these teeth are going to interact with the parts that are here. So when these sliders move, these are going to move as well because they are interacted with the meeting teeth. Let's show you one of these pieces, just one. As you can see, there are teeth in the actual part that interacts with the sidebar. As you can see, there are two false gates and one true gate. And those false gates are actually pretty deep, so it's going to be very difficult to escape from that false gate when you're biting in deep. So it's best to set the true gates as much as possible without falling in too deep. Anyways, this is the part where it interacts with the sidebar. Now the different part. The actual part that interacts with the key is much more simpler. These are the almost the exactly same sliders, but they have little nubs inside so that the keys can move them with the slider tracks on the key. So this is currently arranged as this key's bitting. If we remove it, this is the neutral position. If we put the key again, this. Basically, how this works is that it's kind of hard to demonstrate because this is disassembled right now, but if done right, and it's kind of hard to do it right. Hang on, let me get this working. Okay, I gotta use the sidebar to demonstrate this. It's going to be much more easier to hold these things into position. So what I'm doing right now is I'm going to pick this, arrange them on the middle side so that the sidebar can drop in. Now what's not set? Let's see. I think they're almost done, but a few are... Whoops, I dropped it. Not good. Yeah, as you can see, this sucks. This sucks to play with. And also, as you can see, I did not go through like in a demo or anything. I think this is all in the false gate right now. Let's see. Gotta use a pick. It's going to be easier. Okay, there we go. Oh, the sidebar is in. So as you can see, this upper part, this can move in and out. If they are in, these teeth are going to meet. So the sliders are going to move the actual upper slider piece. But if this piece is aligned like this, the teeth are not going to meet. So inside the core, the sidebars are still going to be pressed in, so this piece is not going to move, and so are the teeth. But the down part, the sliders that actually interact with the key, can freely move because they are not bound with the teeth and they are moving on the spaces between the teeth, so they can move freely, which means the key can be just removed and a new key can insert, and after that this piece can go back and the teeth are going to still meet, so that means the bitting is now going to be changed. As you can see, the difference with the change key and the normal key are very simple. The bitting is same, but as you can see, the change key has a little bit extended part on the end of the key, so that means the change key is a bit longer. What that does is there's this little piece, spring-loaded piece on the tail piece. There's this spring-loaded piece. This is literally spring-loaded. There's a spring inside, and this is a piece. So the normal key does not have enough length, so it's going to just end up like this and rotate the core. But the change key has a little bit more length so that it can actually push in this spring-loaded part. I'm covering with my nail. Can push in the spring-loaded part. What that does is that when in here, this is in, so is the core. I gotta show the piece again. Shit. Okay, so there's this little groove here, and that groove meets with the extrusion on this part here. So when the normal key is inserted, the operating key is inserted, and you turn the core, nothing really happens because this piece is not pushed in. So this piece is not going to meet with this or anything. It's just going to turn the core. So this part is going to turn the tail piece. But if the spring-loaded tail piece is pushed outwards this way, that's going to cause some different actions. First, this piece is pushed in here and it extends out here. This part actually meets with this groove on the core. And if you turn, that piece is going to push this outwards. Because in the neutral position where this piece is up, this part is going to be here, where the sidebar is. If you rotate it 180, two things happen. This metal piece is going to stay here, but the core turns, and that just basically what it does is, let's say this is the metal piece and the core turns. Okay, that was not a good example. Let's say this is the metal piece that's sticking out. So it turns, and when it goes 180, this happens. It's going to push this part outwards. And in order for that to happen, the tail piece also should cooperate because there's this extrusion. If the core turns and the metal piece wants to push that out, but there's no room for that extrusion to go in, which means this part is not going to be pushed outwards. However, if you use the changed key, this thing is going to be pushed and is not going to rotate, even the core does rotate. And when that happens, when we rotate to 180, this extrusion is going to meet this little groove and the upper part is able to be pushed inwards. And that basically separates the two slider pairs, and that makes us able to remove the key and insert a new key in order to make it work, and the bitting is changed when the key is removed. Basically that. So I explained it in a kind of convoluted way, but basically this is just almost the exact way how a smart key mechanism works. The sliders are two different pairs, and when you use a change key or change tool or anything of some sort, the two slider pairs are separated, and if you insert a new key and turn into neutral again, then they're joined again, and that makes us the key with a lock with a new bitting. So that's that. It's a pretty neatly designed lock, and despite this lock looking very simple to pick, it's actually very tricky. Yeah, very tricky. So it's a well-made lock, and I think I explained how the change mechanism works. I tried my best, but as you can see, I did not rehearse through all of this. And if you actually have any questions, or I cannot understand this part or something like that, feel free to ask me on either Discord or comment on the video. I'll try my best to explain more how this actually works, but this is currently my best effort. This is going to be my best effort, and I would love to disassemble more, but as you can see, I struggled. I do not want to disassemble this further. I did once, and I do not want to do it again. That was a horrible experience. I do not want to do it again. But anyways, yes, that was the LS7 picking video and explaining how the change key mechanism works. Picking this doesn't really require the understanding of the change key mechanism, but I just wanted to make this video because I did not find any video online that explicitly explained the workaround of the mechanism. It's pretty cool. It's neat. I love how well is this made, but general picking tips is that it goes same with all Japanese lever locks, as I mentioned. There are levers that are going to be clicked on the true gate from the beginning, and there will be levers that go through like one or two false gates before going to a true gate. You have to tackle those sliders as fast as possible, as early as possible, because if you pick all the other sliders and fallen them into a true gate and one of them falls into a false gate, it's going to be very difficult to escape from that false gate without dropping a ton of other sliders. So presetting and configuring, finding out the false true gate situations of each sliders is going to be the key point for picking this lock. But yeah, anyways, I hope that explains a lot, and yeah, I think that's all for this video.